Hello, hi. How are you, everyone? Today we are going to discussing about the crossover experiments, which is in our organic chemistry. So let's discuss what is a crossover experiments and what are the uses of these experiments. Let's start these things. Okay. So what are the methods to determine the mechanism of a particular reactions? Okay. So if you have any reaction, you don't know what is the mechanism behind that. For that, there are several types of intermediates are carbocations, carbanions, radicals are forming in between the reaction, but we don't know what are the intermediates are formed. For that, we have the several methods to determine the mechanisms. Okay, so that there are several methods. So identification of products and determination of the presence of intermediates. Okay, then study of catalysis, labeling studies, group labeling, isotope labeling, crossover experiments, stereochemical studies, kinetic isotope studies. That means effect. Okay, so these things which are useful for the determine the for determination of the mechanism purpose. Okay, for example, you can take the any reactions. You know the product, but you don't know what are the reactants, like what are the intermediates are there. If you see the particular products, you can like imagine, you can get easily what is the mechanism is behind, what is the mechanism is involved. You can get it from the products. Then determination of the presence of intermediate. If you know the intermediate, you will easily find out the mechanism. Then study of catalysis, which will gives like study of catalysis, which will gives you mechanisms also. Then there are isotope labeling. Take some, for example, you can take any like a isotopes. You have any atomic isotope which are present in a particular reactant, which will gives you a specific product, a particular product that will determine the isotope labeling, and it is different from the other experiments. Then crossover experiments, which I will discuss now here. Then there are stereochemical studies also can gives the information about the mechanisms. Okay, so we can discuss about the crossover experiment. So it is the non-kinetic method of determining the mechanism of a reaction. Okay, so what is non-kinetic method means, uh, it it does not give the direct rate of reaction. It will gives the clues and steps. That's all. It does not give the direct rate of reaction of a particular anything. Okay, so it is different from the kinetic methods. Okay, then crossover experiments can determine the nature of intermolecular or intramolecular rearrangement. Okay, in these experiments here, by using of this experiment, we can identify if a particular reaction is intermolecular or intramolecular. We can identify. Then in crossover experiments, there are two similar but not but non-identical reactants are used in crossover experiments. Okay, we are using like two similar reactants, but both are not identical, non-identical. Okay, so that is the thing. If the product of the reaction contains the fragment of both reactants, the product is a crossover product. Understand here, the product which are obtained, it has both fragments, like two types of reactants are there. Then what is there? The formation of crossover products indicates an intermolecular mechanism. You can understand from this line. Okay, how you know the intermediate, like intermolecular mechanism is formed? That means if the crossover products is formed, it indicates intermolecular mechanism. This is the thing what you have to understand. Then while their absence suggest an intramolecular mechanism. Okay, so that is the thing. So here you can understand from these are the two species, like both are similar but non-identical. Okay, this is a tiger. This one is the tiger, and this one is the lion. It's similar. You will see it is not a liger, not a lion. Okay, but it is a female lion. This is the male tiger and female lion, which will gives the tigon, the cross product. You can consider the tiger and lion both are reactants, and the product like crossover product, which is different than the reactants. Okay, so that is a thing. Now you can understand from this concept. Take reactant A and reactant B. Reactant A which will gives the product P1, and reactant B which will gives the product P2 in the presence of any acid or base or any catalyst. Okay, you can get the two types of the products. If you are mix, like if you are mix A and B reactants, you can get P1 and P2. It determines the, like it indicates intramolecular mechanism. If if the product like P1, P2, P3 and P4 will come means, it is like a intermolecular mechanism. There are four products are formed. That means what it is? It is intermolecular mechanism. Okay, so this is the concept what you have to understand. Then I can give the examples: the Fries rearrangement reaction and the Claisen rearrangement reactions. Okay, so this rearrangement produces phenolic esters to 4-hydroxyaryl ketone or 2-hydroxyaryl ketones. Okay, so it is the ortho and para selective, this reaction, and it will depends on the temperature, solvent and other conditions also. So we can perform this reaction like common solvents like aluminium chloride, Lewis acid, and without solvent also we can try this reaction. Okay, so these are the examples. Okay, take the like phenolic esters in the presence of Lewis acid and the heat, it will give the product P1, and like reactant B, you can react with the aluminum chloride Lewis acid in the presence of heat, you can get P2. Okay, if you are react with the P1, like reactant A and reactant B, we can get P3 and P4. That means this is the intermolecular mechanism. Four products are formed. Then Claisen rearrangement reaction. This reaction, it is a sigma 3,3 sigma tropic rearrangement reaction that forms a new carbon-carbon bond. Typically involves the heating an allyl vinyl ether to form like gamma and delta unsaturated carbonyl compounds. And this is an example. Okay, this is this is an intramolecular mechanism it involves. Then these are the applications to predict the mechanism of reaction, whether it is intermolecular or intramolecular reactions are there. So provides detailed information by analyzing the products. These crossover experiments can provide evidence for proposed reaction mechanisms by tracking the movement of the isotopic levels. And these are the references what I used in this like lecturer. And thank you so much. If you are not understanding means give me a comment. I will give the reply and answer anything. Thank you so much. Thank you all.